Hello and welcome to my talk about Magnolia meets OpenTelemetry, a vendor-agnostic observability solution. Just to get a quick overview, can you give me a hand sign who already knows OpenTelemetry? Okay, and how many are using it actively for Magnolia? Okay, great. First, a short introduction about me. I studied computer science in Ulm and gained first experience with Magnolia CMS as a working student at DD25. I was so excited about that a year ago I wrote my bachelor thesis on the conceptual design of a modern Kubernetes-based Magnolia environment. Since then, I'm constantly working on implementing this concept. It should create a standardized setup for all our customers. It should reduce redundant work and unify the deployment. In this way, we want to achieve shorter time to markets for our projects. The main two principles about this environment should be DevOps. Everything about the environment should be declaratively defined, and the whole environment should be deployable with only one command. And vendor-agnostic, meaning that it should not be dependent on any provider for infrastructure. The environment should be runnable on a completely self-managed Kubernetes, should be running on integrated in large existing Kubernetes environments from our customer, running OpenShift or Ranger, and of course, managed cloud environments like AWS or Azure. At the time, we were running around 30 Magnolia instances on basing of this concept, ranging from a KWS cluster I installed and maintained myself, OpenShift environment of one of our customer, and Google Cloud. And of course, the Shadow Tree instance you earlier saw from Marcus. Besides Magnolia and its persistent services, the environment consists of a certification management environment with Cert Manager, continuous integration and delivery workflows with Tekton and Argo CD. Of course, the persistency layers with the cloud-native Postgres operator, a storage interface with Longhorn, and a simple observability stack with Grafana, Loki, and Prometheus. But if you think of the vendor-agnostic principle, these vendors are not really vendor-agnostic. And that's what I thought about 6 months ago. How can I integrate different environments for observability, and how can I integrate these with our existing solutions of the customers? That's what I want to explore in this talk with you. For the agenda, to get everyone into the topic, I will shortly explain what observability actually is and what it consists of. Then I explain the role of OpenTelemetry in the world of observability. That's already enough with the theoretical part. Continue with the practical part. I want to explain how you can implement OpenTelemetry into existing environment and show use cases how we benefit from the out-of-the-box experience from OpenTelemetry. What is observability? The definition is the ability to understand the internal state of a system by examining its outputs. Sounds a little bit complicated. Let's break it down. The system means the running environment of Magnolia, consisting of additional backend services or external subsystems. The state of the system means, why do my system behave like this? Mainly for debugging. Okay, we want to solve problems. How can we do that? With the outputs. In OpenTelemetry, they are called signals. They are divided into several kinds of signals. The first one, I think everybody knows, logs. Logs are time-stamped text records, best structured in JSON for querying and with additional metadata. Metrics are a measurement of a service captured at runtime. It not only contains the measurement itself, but also which time it was captured and associated metadata. In the example here, you can see the JVM threads current. That's a metric. And tracing, it's a little bit more complicated, but it's in general the path of a request through your applications. The request is called trace, and it's split up into individual spans. Spans can be, for example, the communication between microservices or individual operations, like a database query or the execution of a particular method. For example, the initial GET request of the status endpoint, you can see here, is the initial span which makes up the trace. But in case of the status endpoint, the database query it triggers is also part of this trace and another span. And the individual requests in their hierarchy, in their time relationship, they make up the whole trace. And also the part of observability is your system to instrument that emit signals. And for the uses of the signals, these must be aggregated in the so-called backend, for example, Elasticsearch. And the backend is then queried by a front end, for example, Grafana. Okay, but what signals do I want to observe, and how and in which format are they emitted? These are the questions explained the need of OpenTelemetry. It's a framework and toolkit designed to be the standardization for all kinds of observability. Although it's relatively new, having been founded in 2019 as a cloud-native compute foundation project, it's already achieved widespread adoption within the community. In fact, it has become the de facto standard for observability and is the second largest cloud-native compute foundation project right after Kubernetes itself, with a lot of providers who already support it. Here you can just see a few of them. It's important to note that OpenTelemetry is not an observability backend or a front end. You still need something like the ELK stack from Elastic or the LGTM stack from Grafana, but more on that later. It consists most importantly of an API, which defines the signals. This makes it possible to not knowing in your application where to send the data to. We don't need to know what vendor we are using in our application and don't know which backend we want to using. We're just sending our data to. The next component is the SDK. It is the implementation of the API in language-specific libraries. You do not instrument your code with any vendor-specific library. Instead, you instrument your code with open source library and are able to send it data to any backend, any vendor. That's why it's so powerful, and that's why we want to use it. Then a lot of tooling involved to simplify the adoption in your environment, which we are exploring now. With the implementation, the practical part begins. What components do you need to instrument your application with OpenTelemetry to enrich the signals with metadata in processing pipelines and send its data to compatible backends? Let's start with instrumentation, the process on how to configure your application to emit signals, logs, metrics, and traces. Therefore, we are using the Kubernetes operator provided by OpenTelemetry. The operator simplifies the adoption of OpenTelemetry in Kubernetes with an abstraction layer called CRD, Custom Resource Definition. The operator can be installed and configured via Helm chart. In the CRD, you can define language-specific configuration on what signals will be emitted and where they will be sent to. On the existing workloads, for example Magnolia, only one annotation is needed in the Kubernetes manifest pointing to the desired instrumentation custom resource definition. The operator automatically injects the Java agent, in case of Magnolia, into the JVM with all configuration needed. That's all you need. Only one single line, what you want to export and annotate your workloads with this config. For Magnolia specific metrics, we can utilize the Magnolia instrumentation module. It can be installed with Maven or is already installed when you're using the cloud web app. Can you give me again hand signs who are already using the instrumentation module? Okay, not so much. Cool, then I can talk something new to you. It simply provides an endpoint under the path monitoring scrape, which can be scraped for metrics. For the first test, when it's installed, it can be called with this little curl command, completely simple, but you don't get any results from the endpoint. That's because probes are needed to define. Probes define what metrics are exported. And there are a default configuration in the instrumentation monitoring module with the most common probes. But when you do want any additional probes, you can just configure them in the configuration workspace of Magnolia. But where will the signals from the Java agent will be sent to, and which component scrape this monitoring endpoint? That's where the OpenTelemetry collector comes into play. It's proposed it to receive, process, and export telemetry data. Instead of multiple agents from different vendors for different kind of signals, you just need a single unified collection point for every observability signal. The key functions of the collector are organized into pipelines for each signals. And the pipelines, in addition, are divided into receivers, which collect the data from the applications. In our case, the Prometheus endpoint, from example, from the monitoring module from Magnolia, and logs and traces from the Java agent we installed with the instrumentation module provided by OpenTelemetry. Then the process pipeline, which modify, filter, enrich, or aggregate the data before export, and the exporter, which sends the process data to one or more observability backends for storage, analysis, and visualization. To give you an idea on the function of the processing possible with the collector, I give you an example. By default, the trace name exported by the Java agent is just get/star. That's not really helpful. I want to know which site is the trace referring to. And therefore, I can create a processing pipeline which gets the request name, the URL path, and set it as the trace name. But then I also have the parameters of the URL. I don't want to. Easy, just a little regex command to truncate only the path. That's one example. So then you get a nice name. Another example on how to use these layers are the decentralized authentication, because you can scrape and get all metrics and every observability signal unauthenticated because the collector runs in your own Kubernetes cluster locally besides Magnolia. And then the authentication process for external backends can be done in the export section here. The backend and visualization layers are completely interchangeable here. You can use whatever you want, or you customer want, or in best case, you already have. The elk stack from Elastic, Dynatrace, Splunk, doesn't matter as long as they support OpenTelemetry. I set up the LGTM stack consisting of Loki for logs, Grafana for visualization, and Tempo for traces, Mimir for metrics. So with the time left now, I want to assume that these backend and visualization environments are just running. And let's go into use cases, how the instrumented workloads which emit OpenTelemetry, how you can utilize them. They are just our use cases. You can have completely different use cases. It's just an example. I separated the use cases by signal types, starting with metrics. That's part of a dashboard from the Magnolia instrumentation module, giving you insights about the Magnolia filter time execution. You can see a heat map on the timing here, the time distribution here, and down here you see a graph about the min, max, and average execution time. Another example is this dashboard. It's from the Grafana community, giving you insights on the pods with run your workload. You can see the current CPU and memory usage for each pod. And also really important, you get the resource requests and limits. That's important when you're dealing with out-of-memory kills or something like that. Here you can see the reason why, because it spikes and you have the combination of the actual load and the limits. That's really helpful. This dashboard provided more information about the Java virtual meshing. It visualized the memory heap over time. And here you can see the size of different memory pools, like the heap, class space, and garbage collection. And the last graph is about the number of threads in a virtual machine. And you also see, for example, deadlock threads. And for deadlocks, you already also get a quick overview here. If you have any deadlocks, the status bar's getting red, so you get informed about it. Okay, let's move on to logs. Logs have the biggest legacy in telemetry signals because all programming language has already built-in logging capabilities or using log libraries. For example, Magnolia in its default config uses log4j and Tomcat uses the Java util logging. But you don't want to replace these in your code. That's the reason why OTel have a appender for integration with these existing solutions. Most importantly, in our case for Magnolia, the log4j appender. It consists not only, it's not a simple line processor, but it injects the log event to get a more structured information about the log. This is a simple log dashboard I created in Grafana. You can select your Magnolia instance up here. The log level is automatically extracted and shown in the status bar here, where red is the error message, yellow warning, green is an info message. You also get a histogram on how many logs divided on which log level is emitted in the time. And that's everything out of the box. I don't even touch a single line of the log4j config XML. With other logging solutions where you configure the log4j config, you don't get the Tomcat logs, which is really important when you have a problem with starting of Magnolia, because then Magnolia is not even started, you don't have log4j logs, and you don't get any logs. No problem with OpenTelemetry. It has a Julie appender, so you also get the Tomcat logs. And here you can see the metadata of one log file, and you can see Kubernetes metadata like the pod name, and in addition we created a MDC filter which added attributes to the request. For example, the request URL or the Magnolia site name. This can be configured with additional module my colleague Alexander wrote, right? And I just need to define one property in OpenTelemetry and it's get imported. Okay, we don't have much time left, so let's move quickly to traces. It's a function provided by the SDK with a default set called auto-instrumentation. So that's a good starting point to explore tracing without specifying any custom traces, without configuring your code. Let's start with that. Here you can see the GET request of the REST status endpoint and its other request it triggers. It automatically detects that the REST status endpoint triggers the call of the status endpoint status method, which then triggers the SQL statement, in fact. You get a time graph, which is pretty similar to the network tab of the browser development mode. And you can see here, okay, that's the call, and here's the subcall, and you see even the database statement. And that's all without anything configured in the application, just out of the box. Here's the initial request of the contact form from our website. And here you can see that the request is way longer. And the database is just these short times. So I don't know why is this website so slow. Maybe we can find it out with traces. That's where custom traces comes into play. We need to enrich the traces, or we need to enrich the trace with additional spans. How can we do that? The most simple way is zero code instrumentation. We create custom spans just with the span command and can also add parameters to the span, so like attributes, which better describe the span. But I think, okay, maybe let's look how much the render process of remarking takes time. But this is a method which we don't override in this project. So here comes the environment variable into play, where you can just define the package, the class, and the method, and it also get a custom span. Now you can see here that we have the same request with our custom spans, just with the one environment variable pointing to the free marker render method, and you got every free marker render process. And here you can see that most of the time, 1.2 seconds of the total 1.22 seconds is just one render request, and then only at the end other render requests are triggered. So now we need a little bit more information about this trace, but not today because my time is over. Thanks for your attention. If you have any questions, feel free to ask tonight.
Thanks a lot, Mark. Thanks so much. So do we have any questions for Mark on OpenTelemetry? Any questions? I had one question. Is this something that you're thinking about sharing, the configurations that you've provided, or is it something that's anyways available?
Maybe. It's just a pretty default configuration. I don't develop anything new here, but it's also still in a development phase, so I'm not sure if I can share anything useful here. But
that's okay.
If you're interested, just talk to me.
Sure, sure. Any questions? Okay, thanks a lot, Mark. Appreciate it.